Okay, so let's do this question quickly. This question was asking for isolate the output variable and record the answer in function notation. So first step is you want to do BEDMAS backwards to get that output y by itself, okay? So you do that by doing, BEDMAS backwards suggests that we need to do addition and subtraction first. So I'm going to subtract 4 on both sides because right now here is untouchable. And when I have as the next step, I have square root of 2y minus 3x is equal to 10. All right. So reminder that what's the opposite of squaring? Well, square rooting, just like for adding, the opposite of that is subtracting. So if I have 3 squared, if I want to get rid of that squared, I want to square root it, because why does that work? Well, there are a couple ways of looking at it. That's the same thing as writing square root of 9, and that is equal to 3, right? Another way you can think about it is, well, these cancel right away, and so it's equal to 3 right away, okay? Opposite of squaring is square rooting, okay? So that's the one step you have to remember for this question. So once we square both sides, so let me just write down square root 2 minus 3x is equal to 10. I rewrote that step so I can show you that I'm going to square both sides. So you might have noticed a mistake here. I should actually have 6 here because 10 minus 4 is 6. So here I'm going to say square both sides, because what you do to one side, you have to do to the other. And so you get 2y minus 3x is equal to 36. I want to get y by itself. So I want to do BEDMAS backwards. Based on that, I want to add 3x to both sides. Same thing as saying move the 3x to the other side. I get 2y is equal to 3x plus 36. I'm going to divide by 2 to all 3 terms. Therefore, I get y is equal to 3x divided by 2, which works out to be plus 18. Am I done? I'm not done because I need to write it in function notation. So how do I write y in function notation? I have to simply replace that y as f at x. So f at x is equal to 3x over 2 plus 18. So that's the function notation step. Okay, so by doing the following, I've done step 1, which was to isolate the output. And by doing this step, I have replaced it with function notation. So that all of this was kind of step 1, which was getting that output by itself. And this was step 2. Okay.